Hi everyone, so today we're going to continue our discussion about measures of variation. So in the last video, we already discussed range and interquartile range. So for the second part of my lecture, we'll talk about variance and standard deviation. So for this video tutorial, you will learn how to calculate the measures of variation for the given data, that is standard deviation and variance, and also learn how to interpret the measures of variation. Okay, so let's start with the standard deviation. So the standard deviation is the degree for which the data value deviates from the mean. When we say deviates from the mean, we're talking about the distance of each data value from the center of the distribution. Okay, suppose we are given this distribution. So the center of the distribution is actually 5. Okay, so to compute for the deviation, we will use the formula x minus x bar, where x represent the score and x bar represent the mean. Okay, so let's look at let's look at this distribution. So let's have 8 here. Okay, so to get the deviation of the 8 from the center of the data, we will just subtract 8 and 5. So 8 minus 5 is 3. Okay, and then let's have 3 here. Okay, and 3 minus 5 is negative 2. So all you need to do is just to repeat the process so that all the scores will be considered in finding the deviation of the scores from the center of the data. Now, if you will notice, okay, in range and interquartile range, we only consider the two values, okay? So here in standard deviation, we're actually considering, okay, considering all the scores on your data set. That's why the standard deviation is the most used measure of variation, okay, compared to the other measures of variation, okay? So, of course, if we're going to consider all the scores, we're going to have several deviations, and that is not easy to interpret. What we need is to come up with one number. So one way of doing this is getting the average deviation of all the scores. Okay, so let's say we're going to get the average of all the deviations. So what we will do is just to add all these numbers, okay, and then divide it by 10. Okay, since we have 10 scores in our data set. Okay, so let's call it the average deviation in the meantime. Okay, so what we will do is to add all the deviations and then divide it by the total number of scores. Okay, so negative 3 plus negative 2 plus negative 2 plus negative 1.5 plus 0 plus 1.5 plus 2 plus 3 divided by 10. Okay, so negative 3 plus negative 2 plus negative 2 plus negative 1.5 plus 0 is negative 8.5. And then 1.5 plus 2 plus 3 plus 3 is 8.5. So negative 8.5 plus 8.5 all over 10 will give you 0 over 10. So 0 over 10 is actually 0. Okay? Which doesn't make sense at all. It is not meaningful in our data set because as you can see in the distribution, the scores are spread out. So we cannot say that the average deviation or the average distance of the scores, from the mean is 0. Okay, it doesn't make sense. So what we can do is to do some manipulation so that we can get a better result. One way of doing this is taking the square of each deviations, okay? So that all the negative deviations will turn into positive. So when we take the square of each deviation and then taking the average of the squared deviation, we're actually computing for the variance. Okay? So squaring the deviations and taking the average gives you the variance. Okay? And then once we take the square root of the variance, it actually gives you the standard deviation. Okay? Now, why do we need to take the square root of the variance? Okay? So try to imagine if your data is in meter, okay? And you take the square of each deviations. So the square deviations will now be in square meter. Okay, so it will be a challenge to interpret when the unit of measurements are not the same. Okay, so to go back to the original measurement, you need to do the opposite of squaring a number, and that is taking the square root. Okay, that's why we use um, we use standard deviation mostly. Okay, compare to variance. Okay, so using the formula, the variance, we will use the symbol s squared here, is equals to the summation of x minus x bar squared all over n. So the summation of x minus x bar squared represents the sum of squared deviations. And then your n here represents the total number of scores. And then to take the standard deviation given by s, you just get the square root of the variance. So that is summation of x minus x bar squared all over n. Okay, let me show you a step-by-step guide on how to compute the variance and standard deviation. Suppose we have the scores of 5 students in a math exam. So we have 3, 5, 11, 13, and 18. So to calculate the variance and standard deviation, the first step is to calculate the mean. Okay, so to calculate the mean, x bar, we will add all the scores and then divide it by 5. Okay, since we have 5 scores. Okay, so 3 plus 5 plus 11 plus 13 plus 18 divided by 5. So 3 plus 5 is 8, plus 11, 19, plus 13, 32, plus 18, 50. So 50 over 5 is 10. Okay? So do not forget your mean is 10. Okay, we will use that later when we take the deviations. Okay, and that is our second step, finding the deviation of each scores from the mean. So we can create a table like this so that it will be more organized. Okay, so remember our mean is 10. Okay, so to calculate the deviation of each scores, we will just use the formula x minus x bar. Okay, so 3 minus 10 is negative 7, 5 minus 10 is negative 5, 11 minus 10 is 1, 13 minus 10 is 3, and 18 minus 10 is 8. Okay. So these are all the deviations. Okay, what we will do next is to square all the deviations. Okay. So negative 7 squared is 49. Negative 10 squared is 100. 1 squared is 1. 3 squared is 9. And 8 squared is 64. Okay. After we take all the square of each deviations, what we will do next is to add all the square deviations. So 49 plus 100 is 149, plus 1 is 150, plus 9, 159, plus 64, 223. So the sum of all the squared variation, or the summation of x minus x bar squared, is 223. Okay, so after you add all the squared deviation, it is now easy to compute the variance. Okay, we will just use the formula. Okay, so plugging in the sum of all the squared deviation and the total number of scores, we can easily calculate the variance. Okay, so the summation of x minus x bar squared is 223 divided by the total number of scores, which is 5. So 223 divided by 5 is 44.6. So the the variance is 44.6. Okay? And to calculate the standard deviation, we just need to get the square root of the variance. Okay? So taking the square root of the variance, okay, so our variance is 44.6. So the standard deviation will be the square root of 44.6. So the square root of 44.6 is 6.678. Okay, so 6.678 is our standard deviation. Okay, so remember, all you have to do is to get the square of the deviations, get the sum of all the squared deviation, then divide it by the number of scores, and that gives you the variance. Okay, and for the standard deviation, you just need to take the square root of your variance. Okay, let me show you another example. Okay, so a greengrocer purchases oranges from two different wholesalers. He takes 5 random crates from each wholesaler and counts the number of blemished orange in each. Okay, so the scores represents the number of blemished oranges. Okay, the wholesalers are Sun Blessed and Valencia Star. Okay, so we are asked to find the mean and standard deviation for each data set and compare the wholesale supplies. Okay, so it means after we calculate the mean and standard deviation, we need to interpret it. Okay, so let's start with calculating the mean and the standard deviation for sun-blessed oranges. Okay, so I put a table like this so that later on it will be easy for us to calculate the standard deviation. Okay, so let's begin with calculating the mean. So we will just add all the scores. Okay, so 4 plus 16 plus 14 plus 8 plus 8 divided by 5. So 4 plus 16 is 20, plus 14, 34, plus 8, 42, plus 8, 50. So 50 divided by 5. So your mean is 10. Okay? So this is your mean. Okay, next step is to get the deviations. Okay, take the deviations of each scores. Okay, from the mean. Okay, so 4 minus 10 is negative 6. 16 minus 10 is 6. 14 minus 10 is 4. 8 minus 10 is negative 2. 8 minus 10 is also negative 2. After we take the deviations, okay, after we take the deviations, we're going to square it. Okay, so negative 6 squared is 36. 6 squared is also 36. 4 squared is 16. Negative 2 squared is 4. Negative 2 squared is also 4. Okay? Then we take the sum of the square deviations. So 36 plus 36, 72 plus 16, 88, 92, 96. Okay? So using the formula and calculating the standard deviation, that is the square root of the summation of x minus x bar squared all over n. So plugging all the values will give you the square root of 96 all over 5. Okay, square root of 96 over 5 is 4.38. So your standard deviation is 4.38. Okay, so recap. For sun-blessed oranges, the mean is 10, the standard deviation is 4.38. Okay, let's continue to our next wholesaler, which is the Valencia Star oranges. Okay, so we will calculate the mean first. So 9 plus 12 plus 11 plus 10 plus 13 divided by 5. 9 plus 12 is 21 plus 11 32 plus 10 42 plus 13 55 divided by 5. So the mean is 11. Okay, so take note, your mean is 11. Next step is to take the deviation of the scores. Okay, so 9, we'll start with 9. Okay, sorry for that. Okay, so 9 minus 11 is negative 2. 12 minus 11 is 1. 11 minus 11 is 0. 10 minus 11 is negative 1. 13 minus 11 is 2. Okay, after we take all the deviations, we will square it. Okay, so negative 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. 2 squared is 4. Okay, and then take the sum of the square deviations. So 4 plus 1 is 5 plus 0, 1 plus 1, 6 plus 4, 10. Okay. Then plugging it in the formula for standard deviation. So the square root of the summation of x minus x bar squared all over n. Okay, so the sum of all the squared variation is 10 divided by 5, so that gives you square root of 2. So converting square root of 2 to decimal, so square root of 2 is 1.41. So your standard deviation for Valencia Star oranges is 1.41 and the mean is 11. So we already calculated the descriptive statistics, the mean, and the standard deviation. Let's now compare the result. Okay, so the mean of Sunblest is 10, Valencia Star is 11, the standard deviation of Sunblest is 4.38, Valencia Star is 1.41. Okay, so Sunblest has a lesser mean than Valencia Star. So what we can take note is Sun-blessed oranges has lesser blemishes than Valencia Star. Okay. Next will be the standard deviation. So as you can see, Valencia star has a lesser standard deviation than Sunblest. Okay, so we can say that the data of Valencia star is more intact, okay, than Sunblest. Okay, so it has a lesser variability. So let's write it down. So Valencia star has lesser variability than Sunblest. Okay, so that's it. That's how you interpret the descriptive statistics, the mean and the standard deviation. Okay, so I hope you learned from our video tutorial. I will see you in my next class. Okay, goodbye.